magnitude and direction of a vector. So I'm considering 4 different vectors with the components. The first one, if you see, the terminal site will be in quadrant 1. Second one, terminal site will be in quadrant 4. And number 3, terminal site goes in quadrant 2. And just take a moment and see if you understand what I have said. So first let me find the magnitude. For the vector u, components are 8 and 9. So the magnitude will be 8 squared plus 9 squared. So you get 64 plus 81, which is square root of 145. You can leave it there. The same way, magnitude for second vector will be again square root of 145, because you will write 8 squared plus negative 9 squared. And all the 4 vectors will have magnitude square root of 145. So my main focus will be on how to find the direction of each of these vectors. So first of all, let me plot this vector number 1. So you can see this is the vector u. So 8 units going on x-axis and 9 units goes on y-axis. So the angle between the vector with x-axis will be theta, and then we can find tan theta equals 9 over 8, rise over run, you know. So then theta will be arc tangent, or you can say tan inverse 9 over 8. So in this case, you are done. You can take a calculator and find the radial measure of this. So if you look at theta in the first quadrant, and it is between 0 to 1.57, pi by 2. So this measure is acute. We are done with this. Now we look at the second vector. So as you see in the second vector v, I have 80 squared is 64 plus negative 9 squared gives me 81. So I'm getting the same magnitude, square root of 145. Now I'm looking for theta. So if you plot the point 8, negative 9, so you have 8 units, negative 9 units. So this is the vector going like this. So we're looking for this angle here. So that angle, how we find? First I will find the reference here. So the reference will be like this. You say arc tangent 9 over 8. And since this one is going in my fourth quadrant, so I said 2 pi minus. And then we'll verify this one now using graphing calculator. So I hope you have understood that why I am taking arc tangent 9 over 8, though I have components 8 and negative 9. I'm taking reference angle here. And then moving it to the fourth quadrant. So how I move it to fourth quadrant? 2 pi minus the reference angle. So that gives me 5.4390. Now as you see here, this is 1.57 or pi by 2. This is pi 3.14. This is 3 pi by 2, 4.7, and it's more than that. So look at 5.4390. So that makes sense. So this one is here. The same way we'll do number 3 and 4. We are now for number 3. So the magnitude will be 64 plus 81 under the radical sign. That gives me square root of 145. And you know why. You take negative 80 squared is 84. 9 squared is 81. Add them. Now, as you see, negative 8 goes on the left side and then 9 goes up. So my terminal point is in quadrant number 2. So my vector is making angle theta with x-axis must be more than pi by 2 or more than 1.57. So how do you find this? First we'll take the reference angle 9 over 8. So we used to say arc tangent 9 over 8. And since I'm in second quadrant, I just say pi minus. And then grab a calculator and see whether it is below 3.14. And you can see clearly, when I put it in the calculator, pi minus arc tangent 9 over 8, that gives me 2.2974. And you can see here, that's the angle, more than pi by 2, less than pi. That's it. So same way, try number 4. Negative 8i minus 9j. It is on the left side and it's going down. So the terminal site is in quadrant number 3. So my theta will be more than pi. So let us see what happens. So first I see I need to add pi plus arc tangent 9/8. So use your calculator and see what is the answer you are getting. That exactly matches, you see. Is pi, which is 3.14, and it little more. So that brings your terminal side to quadrant number 3, and we are done.